Hello, good morning to all of you. You're very welcome to this workshop where we invite you to join us on a journey to the world of raw materials. My name is Hanno Bertignol. I work here in Leoben at the EIT Raw Materials Regional Center. And I'm joined today by Andreas Oberrauner from GeoConsult in Salzburg, Markus Heupel from About, and Rob Pell from Minviro in London. We want to take you to a journey to the beginning of the world of raw materials, as I said, and we want to share with you some ideas about why we are concerned about raw materials. And we want you also to get involved into this, to share your questions with us. So please feel free to ask as many questions as you would like, and we will group them and answer them or try to answer them at the end of this workshop. Did you know that, is the screen shared now? Oh, sicher.
It is not shared yet. Now it starts sharing. Yeah, okay.
I do apologize. As I said, we want to take you to the beginning, and the beginning looks a little bit like this for every one of us. And from that point onwards, the next 70 years, every one of us is going to consume about 1,370 tons of raw materials. We need a vast amount of materials for nearly all aspects of our life. And in this picture, we see just a few examples of what aspects we're talking about. For instance, 42 different metals are in everyone's computer, 70 different minerals, metals, and elements. Nearly half the periodic table are within one smartphone, and so on. The need for raw materials increased during the last centuries, and not only in volume, but also in diversity. We now consume much more and a larger variety of raw materials than ever before, and the trend is going. Now, can this massive consumption be stopped somehow? For instance, by changing from brown to green technology? Not really. Renewable energy sources like the sun, the wind, they are indeed renewable, but it requires a lot of material for the transformation systems. I will give you one example. And to give it into more details, we can look at these figures that the World Bank published last year. If we now look at materials from only the energy technologies, raw materials required for getting the energy technology up and running, most of these metals, most of these minerals, for instance, lithium, cobalt, graphite, they will be needed in a much larger quantity that we now are producing. So we need to prepare for this. One example is a wind turbine, a standard large-sized wind turbine in the range of 3 megawatts. For building such a unit, you need 330 tons of steel, 1,200 tons of concrete, 4.5 tons of copper, 3 tons of aluminium, 2 tons of rare earth elements for just one unit. Where do these materials, where do these minerals come from? Where do all these things come from? This is the question that we need to find a solution for. And as the wise man once said, if it can't be grown, it has to be mined. And this is where EIT Raw Materials comes into the picture, because most of the elements that are needed currently are imported from countries in Africa, in Asia, which are politically unstable. So how can we make sure that within Europe, we will still have enough quantities of that materials available? EIT Raw Materials has been founded to address exactly this challenge. It is the world's largest community in the raw materials sector, comprising more than 300 partners from all over Europe, 22 countries roughly, and it covers the entire raw materials value chain. When I talk about value chain, what do I mean? Everything starting from how can I find a mineral resource, how can I find some minerals in the earth crust, to the processing, to the production of goods and services, and recycling in one life, in one loop. How can raw materials do it? The vision of raw materials, EIT Raw Materials, is to develop raw materials into a major strength for Europe. And I would add again, because a couple of 100 years ago, this was exactly the case. How? We want to enable competitiveness of the European industry that is sustainable. We want to invite everyone to join a community of research institutes, of businesses, of universities to do something together in 3 strategic fields. One field is to make sure that the raw material supply is safe, designing materials solutions, and to close the loops of materials, similar to the graph that I have explained before. Thematically, these are 3 fields that we cover: sustainable discovery and supply, I mentioned already; sustainable materials for future mobility, for electric vehicles, battery, etc., and raw materials for circular society. We support businesses that do things that have not been done before. We support smart people that have a good idea and want to have this idea transformed into a market product, to bring a good idea into the market. From inventing an idea, build up the business, and be able to run the business. Education is also important in this whole game, because the people that you educate today are the engineers of tomorrow. This is something that is not entirely new, but a big focus of EIT Raw Materials also. We call it the EIT Raw Materials Academy. And coming to the end of my introduction here, I would like to hand over now to Andreas. Andreas Oberrauner is from Geoconsult in Salzburg, but he will explain it a lot better himself. Andreas, can you tell us what you do and how you got involved in or with EIT Raw Materials, please?
Sure, I can. Thanks, Hanno. What I want to show you quickly is I don't want to say I'm one of the smart guys that's invented something and now is bringing up business, but I got in contact with EIT Raw Materials years ago, basically, and we have tried to develop a special service that connects the demand for raw materials in a broader picture, but also the ability of mapping underground structures that are there and need to be integrated in a system with the service that we kind of invented. So how can I share my screen? Like this, obviously. And now here we go. Okay. So the project I want to tell you quickly about is called US Underground. Started last year, and we're coming closely to the end of it. And what we try to do is we want to bring drones in an underground environment, map this environment, which is kind of inaccessible for people to walk, to drive. And we're doing this together with GeoConsult, that is an independent mid-size enterprise based in Salzburg, and roll that service out with support from the EIT Raw Materials. We're currently in a booster call funding program, and on this first slide you already see an application for that, where you see about 160 meter high vertical shaft with a drone flying up and inspecting and mapping this shaft. So this is not just a concrete shaft; it's a drilled shaft in surrounding rock. So you also see geological structures in that, and you can closely map this with the drone. So this is one of the tests we did. How do we work? So we, for instance, use UAVs, so drones in a cage, basically protected, so that the rotors are protected for industrial mines, for historic mines, for any caverns you can imagine, maybe for tunnels, for shafts. And the key then is, if you know, these drones are basically data collectors, and then you have to get the data out and process it. And this is the second step. And the third step in that is where the engineering capability comes in, where you start to interpret the data that the drone collected, and integrate the data into an information that the clients can use in their systems, whatever it is that they have in their enterprises or in their organizations. Obviously, as you see on the pictures on the bottom, we try to, do our hardware, make it quite robust, because underground is not a very smooth environment. It's quite harsh. Sometimes it's wet. It's obviously dark, so you need some light on it, and you also need some skills to fly those things underground. So on the right side, you see our team that does an inspection flight here with computer goggles, and a client sits there and tells us where to go and so on. So a local person can live view that. Some impressions here. One of the drones that we have basically set up is it's a drone that you can order on Amazon. We try to use cheap ones here, in this case a Mavic enterprise drone with a self-built carbon cage and some LED lighting on the outward part of the cage, and then we fly through those underground structures and do 3D models. So based on photogrammetric models, we get them out of here, and we process them in commercial software packages like Pix4D, for instance. But also we are doing geological analysis in our in-house software that GeoConsult develops ongoing. That's called TUGIS, so Tunneling Geographic Information System, if you want, where you can also map geological structures that you see in these models. So we try to do that very accurately, and you see some of those outcomes here in the pics. Here's another kind of weird view of an underground historic stoping, where you can hardly access it on feet, so you have to fly it up. It's unsafe. It's something if you can do it in your free time, but not in a professional framework. You cannot walk in there. You see on the right side of the picture the person, the engineer, so to say, that controls that flight, and in this cage that you saw before, moves around in there, has enough light to produce a model and to have enough data to calculate a photogrammetric model, basically. The other thing that we do is more the inspection side. So we're not modeling, but we're going to underground environments with small drones that are easy to build, kind of cheap, below 1,000 euros, one of them. So there is a lower threshold, a lower risk. When you lose them, you get another one. The commercial drones that are out there for mapping, they usually start at about 20 to 25,000 euros a piece. So who can take the responsibility to fly with a very expensive drone through such harsh environment? Well, our approach was to have cheap ones, and it's pretty amazing what you can do with them in terms of where you can actually access, not only in mines but also in infrastructure, buildings. I saw a video of sewers that can be inspected, and we have first clients that come from that area. So public infrastructure. Okay. Why do we do that together with EIT Raw Materials? Well, they have good funding instruments. We are currently in the booster call startup funding instrument. And for me, what I like about it is that they challenge you. It's not you put in some technical idea and they give you some money, and then you can burn that money and then you write a report and that's it. But you are more forced to develop the technical idea that you have in mind in a structured way. And on the other side, you also have to integrate a marketing concept, a go-to-market approach, a business model around that. In whichever way you do it, then you go to a pitch and you're challenged. And if you make that, you get first, money that you need, and then the amount of money that you get is so that you can do significant actions like we did, building of drones, traveling around, hook up with some clients, access their sites and so on. And the other thing that I liked about it, this booster call, is that EIT Raw Materials also provides you with networking possibilities. So they bring in contact with potential clients, with the academia also, and for the next step that you come in, this is basically the broadening of your customer base, so that you get to know clients and can build the business. So from the inventing phase, as Hanno showed in his presentation, to the bring a business phase, kind of. So I hope that works, which is not so easy in this pandemic, but yeah, everybody knows that, obviously. And okay. Here, just a snippet I got from the internet. The connection between software companies and the mining industry. So Epiroc, which is a company that is formerly, or better known as Atlas Copco in former days, completes the acquisition of a software company for increased mine productivity. So MineRP is a company, I think they started in South Africa. I was there once at their office, and yeah, they put out services to the mining industry, and now a major supplier of equipment has bought them, because they see a significant potential in acquiring such companies. Okay, that was just an input I also got. So if you can write me emails, if you have questions about what we do at mining@giaconsult.com, also via Hanno. And that's it from my side for now. Thanks.
Thanks a lot, Andreas, for this nice overview of what you are doing and how you got involved with EIT Raw Materials. I would like to hand over to Markus now and ask him. He also works in the mining and construction industry, but in a little different field. Markus, please. You're still unmuted.
No, so you can hear me?
Yep.
Perfect. So thank you for the introduction, Hanno. And thank you, Andreas, for your very nice presentation. So you spoke a lot about underground mining. I will be more concentrating on the surface part of that. So my name is Markus Heupel, representing About, and in behalf of our team of 13 people, I thank you for the chance to introduce our services within this gathering and also tell a little bit about our connection to EIT Raw Materials. About itself is active in mining and construction, and we use very similar technologies there for automated recognition of operational processes in both industries. And throughout our journey, we already acquired important partners out of the mining and construction industry, especially with EIT Raw Materials. We are in a very fruitful contact since March 2019 already. A very high complementary team with mining and infrastructure background, and now comes the software days into the game. Extensive experience in artificial intelligence is the driving spirit of About. So within their supply chain of the mines, About supports mines and quarries at the very beginning in mining and logistics. Today, our customers are on their way to the mine of the future, and About can help them on the way, applying newest computer vision and sensor data analytics in mining. So presentation just stopped for a while. I will go on. So together with us, these mines, they can overcome typical mining problems. Like we heard from Andreas before, optimizing performance is a very important key to automate the info flow from pen and paper to automation, and to minimize non-production idle times and unneeded driving, for instance. On the side of the customers, the best way to gain momentum can be a first start with easy and safe changes, receiving fast results out of real-time action. And on the other side, About will support these customers on the track of digitization transformation, providing a system that is a plug-and-play solution, OEM independent, providing immediate measures, delivering insights to improve the mining operations with no initial investment. Now let's take a visit in a mine, and it's quite easy. We will follow the material that is extracted and transported throughout the mine. Firstly, different sensors and cameras are needed according to different events that shall be analyzed. The mobile sensors are mounted onto every mobile mining machinery. So the first event after drilling and blasting is digging and loading the material onto trucks. We fully automatically recognize time and location of that event. To investigate problems, a live view available allows a better communication between the operator and the mine foreman. The next step then would be to unload the valuable ore at a specific dumping place. Also, that is recognized fully automatically through our algorithms. Different byproducts and waste needed to be transported to designated areas too. And then knowing these both events, loading and unloading, allows us to report the mass balance and mass flow analysis. By knowing the cycle times and haulage distances, the performance of the transport can be analyzed very quickly. But what is the reason why the trucks are slowing down at a specific section of the transporting route? That reason can be answered by combining sensor data and picture analysis of that event. The utilization of loading and transporting machine is crucial in mining operation, and we can give you a closer look on that. Mines always try to improve their blasting pattern and explosives, and by analyzing the grain size versus the digging time, now you can go into detail with your optimization efforts. Additionally, outbound logistics are to be observed and the data is collected similarly. Knowing valuable information of the mass flow from drill to mill is the key in optimizing mining operations. And last but not least, all data are collected and an automated analyzing and reporting system with various different possibilities is done. One of About's specialities is to transform collected data into valuable information for mining and quarrying operations. There are a lot of graphs and data tables available, but most helpful are maps with different layers showing the real action. So I just give an example, a drone flight, the very actual one with all the information prepared, the real-time position, the path of the machine, loading and unloading areas automatically recognized, loading times, working areas, so geofences, non-productive times, idle times, and speeding areas, something like that. Also about delivers pictures and analysis by combining computer vision and sensor data. And here are some common use cases. So grain size versus sticking time, picture, video, and data combination. The next would be to detect potholes on road condition, to do that in sensor and picture data, data fusion. And last but not least, logistics, where we are able to find out lots of things in terms of cycles, speeding, loaded material, and so forth. So the network effect, we call it, from EIT Raw Materials. You see, we started quite a bit earlier as Andreas. So 2019, we were in a booster program, but EIT offers really a very valuable acceleration phase program. Phase 1, 2, 3 means invent, build, and grow. And they really challenge you. You can enhance your growth, you can enhance the business, you build up the business strategy, and that is very valuable for a startup that starts in an industry that tends not to be as fast as possible where it could be in terms of digitization. But it really helped us, and we have a really good effect on then how we develop. So thank you very much for your interest. If you want to contact me, write me an email, and we can get in contact.
Thank you very much, Markus, for this story, how you got into contact with EIT Raw Materials and how the community helped you to grow the business in the phases that you described. I would like now to move west to England and ask Robert to share with us how he got involved with the EIT Raw Materials and which part of the mining industry are you concerned? Robert, please.
Perfect. Thanks for the introduction, Hanno. And yeah, great presentations before this, very interesting. And I think it aligns very well. So yeah, the company is called Minviro, based in London, also have offices in the Netherlands, and also work a little bit in the US as well. So, you know, what we are focused on is driving sustainability of the raw materials sector. So we're very passionate about supporting in the raw materials of the low carbon economy. This first slide is just highlighting, you know, how important sustainability and quantifying environmental impacts is for the industry as a whole. So you can see this is a sort of a risk list from Ernst & Young for mining companies. And you'll see that very high up on these risk lists is license to operate, decarbonisation and green agenda. And we're basically looking to support with this aim. So there's a lot of claims in the mining and metals industry about lower CO2 emissions, low carbon technology, minimum water use, environmentally friendly and sustainable. But what we're saying is life cycle assessment is the approach that should be used to quantify the impact of the products coming from this. And we've developed tools with the support of EIT Raw Material Booster to be able to do this. So, you know, before I go too much into this, I think it's just good to give a high level overview of what life cycle assessment is. You may have heard of things such as what's the climate change impact of a product. So life cycle assessment is an approach where you can quantify that. So you take into account all raw materials and energy inputs into a process and all the associated emissions, whether that's to land, air, and water. And then you're translating those inputs into impacts through the use of characterization factors. And there's very consistent standards from ISO for conducting this. And you can generate a whole range of impacts, such as climate change, but other impacts such as water use, land use change, acidification, eutrophication. And just to give you context, you know, we're measuring the impact of producing the materials, and it includes the impacts with the, you know, the upstream reagents and consumables and the electricity. So that's what we're looking at when we're doing these models. And the reason why we're in such a, you know, this is the time to make sure we're doing this in the right way, as Hanno, you know, very clearly highlighted. We're at the precipice of a raw materials revolution, which is being driven by the transition to a low carbon economy. This low carbon economy needs lots of different infrastructure, lots of different raw materials. And so we sit at a very good point in time to select projects that have the lowest impact, but also make sure that those projects are developing in a way that minimizes environmental impacts. And so you'll just see this graph just highlights there's you should be assessing the options at a project during the development stages, before all the the money's been spent on infrastructure, and before all the infrastructure's actually gone into place, so you can design projects for minimum impact. So what we did is we've developed, this is through the support from EIT Raw Materials, we've developed a tool called Mine LCA. This tool basically speaks the language of a mining engineer or a CTO or a mining practitioner. They can just put in data. So you can see this first slide highlights, what stage of the project are you looking to assess the impact of. So you can see right at the cradle of the project, from the mining phase, whether it's open pit or underground. You can include the impact of crushing and grinding, even further downstream, which is the beneficiation, which is just the processing of the raw materials, and even the refining stages. So, right from the ore out of a mine to a high value refined metal product that might be used in a high tech application, you can include all those stages. It basically speaks the language of a mining engineer. They can put in data about their project. This will include things such as energy and material use, what types of equipment they're using, and also some other aspects about project infrastructure. And also what we've built into this as well is we know that there's data gaps in these development stage of projects. So there's lots of automation options. So if you only know certain parts of the project data, then the rest of the data can be auto-filled from the significant background databases that we've developed over the years. So that can be done quite efficiently. And then once you've filled in all the data relevant for your projects, you can review the impacts. So, this is just highlighting what it might look like from if you're including a mining and crushing and grinding. So you can know exactly what the impact of a product that you produce is. And you can even, and then, here, this is highlighting in a little bit more detail as you dig more into the detail of the project. So rather than just looking at the total impact of, say, the mining stage, you can go into that phase and see, okay, well, is it the electricity that's the impact contributor, or is it particular equipment for the production, or the waste related equipment, or additional equipment even, or is it the water use or impacts related to blasting? So you can really go into as much detail as you want, but the main emphasis is that you can identify environmental hotspots very quickly, very efficiently. And then the option is to simulate impact mitigation. So in this example, we can see that electricity is a fairly big impact contributor. So you could simulate what it would look like if you went 100% renewable on site, or if you adopted, say, a different grid mix. And here's another example of the tool. So we're just highlighting here that we've completed a study, and now we're looking to simulate impact reduction. And this is an example of simulating an electric fleet. So you can just see what kind of impact reduction would occur just at a click of a button. And this really allows companies to identify those hotspots really early on, and can ensure that they put the resources required into mitigating these impacts. So overall, I think the main point I'm trying to say is that EIT Raw Materials has really allowed the acceleration of Mine LCA. We were part of the booster call during 2020, and that really allowed us to accelerate in the development and get our Mine LCA tool to a commercial level a lot faster. And also, I think just also mirroring what was said in previous conversations, it's not just about the financial support. There really is a broad range of support, which includes access to some industry knowledge and connections within the industry as well, which can provide essential feedback for the development of these technologies. And then more broadly, Mine LCA, we're trying to make sure that as we develop new projects, we understand the impacts, and we're minimizing the impact where possible. And also, I think we're going to see this more and more, that there needs to be robust calculations for these environmental claims. And as these sustainability metrics are going to be incorporated into more technical reporting. I know this is slightly the very specific language of mining here about JORC codes and NI 43101, but basically, sustainability metrics are here to stay, and we want to make sure that these are they're the tools out there to make this an easy and effective process. Thank you.
Thank you very much. Thank you very much, Rob and Andreas and Markus, for that overview. And you have three of you have things in common. You provide services to the mining industry, to the construction industry. I'm interested, how did this EIT Raw Materials community help you to get access to customers, potential customers? Some have mentioned it in your little presentation already. Can you give like an example? Maybe Markus to start with.
Yes. What EIT Raw Material provides are different meetings. So local meetings, the EEC meetings, so for East Europe. And you as a startup invited to present yourself. So that gives you access to this community, because one of the most important parts is, do you have a good product? Yes, but you should be known at the end in the industry. And it starts with this introduction, and it also, let's say, ends up in different summits where you could look for different investors, who are interested in investing in your company. So Andreas brought the example of this South African company that has been bought. So there is a bunch of future partners within Europe. So more than 120, what I remember, quite far. That's a very good community, and you can use it when you reach a certain level and a certain stage of your company, of course, to access that bigger community.
Andreas, any question for you? As a youngest in that group?
Well, absolutely. Thanks. I've been part of one of those summits, and admittedly, I was at the very beginning of the booster call, so I didn't take too much of a chance to use it, which not because I didn't want to, but you know, it's, you come into it, and then you have to have, you know, more, the tighter the grip is to a partner, the better you get to know him, the more trust you can build. And I think it's good that these things happen from EIT Raw Materials, and there should be way more of an emphasis here, so because this is really the cake, or this is really the cream on the cake that you did, that you get in contact with those partners, with those potential future partners. And so it's really good, that we started this as a booster call, and I'm really looking forward to to get way more of that in the future.
Definitely, and I also remember, and I'm pretty sure everyone has the same idea that we all are looking forward to being able to physically meet people again.
Yeah,
it's okay to be able to talk via internet and so on, but to talk to customers over coffee, over a beer even, is a lot more intense and a lot more fruitful. And these meetings that Markus and Andreas have mentioned, they are happening very frequently throughout Europe, and offering the chance, offering the opportunity to address people, to talk to them, to share ideas, to share problems. And when you talk about problems, somebody may come up and have, I may have an idea, or I know somebody who has an idea. And that is the beauty, the benefit of this community. Rob, did you have a similar experience also from like what I mentioned, meeting people and being able to share and to network in this community? Did that help you also?
Yeah, absolutely. I think my experience is the project managers that we were working with directly with the booster call were really supportive. They had a lot of knowledge of the EIT Raw Material members and were able to start conversations for us that were really beneficial, not just for direct selling to customers, but also for developing the product as well. Mm-hmm. So yeah, we found it really useful.
Great, thank you very much. And with this, I would like to close this workshop and thank you very much for your interest, for your participation. Many thanks to Rob, to Marcus, to Andreas, to share their view, to share their experiences, really. And you have our contact details, you have our contact addresses. Please contact us if you have an idea, if you want to be part of the community. We are there to help you. Thank you very much. Bye-bye.
Bye-bye. Thanks.
Thank you.